Welcome back to Summarize Science, where we dive into the latest breakthroughs in technology. Today we are looking at a fascinating new approach to how artificial intelligence creates digital art. Specifically, researchers have developed a method called render-in-the-loop for generating vector graphics. Unlike a standard photo, vector graphics, or SVGs, are made of mathematical paths, allowing them to be resized without losing any quality. Most current AI models try to write the code for these graphics blindly, essentially drawing with their eyes closed until the very end. This often leads to messy results, overlapping shapes, and weird glitches because the model cannot see its own progress. The render-in-the-loop framework changes this by giving the AI a seeing eye to match its drawing hand. By rendering the graphic after every few steps, the system provides visual feedback directly back to the model. Think of it like an artist stopping to look at their canvas before adding the next stroke of paint. The researchers found that simply showing the AI the canvas wasn't enough. It needed special training to understand how its code translates to pixels. To help with this, they used a technique called fine-grained path decomposition. Instead of trying to draw a whole complex object at once, the system breaks the process down into tiny, logical steps. This creates a dense stream of visual information that teaches the model exactly how its decisions affect the final image. Another clever feature is the render-and-verify mechanism. This acts as a gatekeeper during the drawing process to detect if the AI is making a mistake or repeating itself. If the AI tries to draw something that adds no visual value or just copies the last step, the system rejects it and asks for a retry. This ensures that every line and shape added to the vector file is meaningful and efficient. When tested, this method showed incredible efficiency compared to existing systems. Remarkably, it outperformed models trained on 20 times more data simply because it used its visual senses more effectively. On the screen, you can see how this feedback loop results in much cleaner and more accurate icons. For example, faces on a laptop screen or complex tools like flashlights are rendered with much higher fidelity. Even with very specific prompts, like a pink camera with blue accents, the model stays focused on the details. Without this visual feedback, AI models often hallucinate or misinterpret where shapes should go. By observing the canvas, the AI naturally learns how to layer objects from the back to the front, just like a human would. Let's recap the most important takeaways from this research. First, closing the loop between code and vision is the key to creating smarter AI artists. Second, breaking complex tasks into smaller steps with constant feedback is far more effective than just using massive amounts of raw data. This suggests that the future of AI isn't just about size, but about how well models can perceive and react to their own work. Looking ahead, these techniques could be applied to more than just drawings. We could see this technology used to build entire websites, 3D models, or even complex engineering designs automatically. By teaching machines to see what they are doing, we are one step closer to truly creative and reliable digital assistants. Thanks for watching Summarize Science, and stay curious about the world of technology.